The sample analysis screen is similar to the replicate analysis screen, so I'm only going to show the differences here, and they're pretty straightforward. Instead of a timeline of replicates, we have a selector over here, a tree selector that'll allow you to find the samples that you're interested in looking at. So we can look at samples here, and by selecting the sample, it pulls up the data for that sample and shows us the calculations. Now basically a sample is a collection of replicates. So this particular sample had replicates run at these 3 different times, and you can see that the dates here span an entire year. So replicates can be spaced over a wider range of time, which is why the timeline doesn't really make any sense in this case. Here we've got 3 different replicates, all done with the same analysis, a CO2 clumped analysis, and we have our values down here. Now these 3 replicates are then combined into one table, and then a sample level analysis is run on it. So the sample level analysis might average values together or something like that, and in this case that's exactly what it does. So here we have average carbon values, average oxygen values for all the replicates that were found in this table. The sample average, or the sample analysis that's been chosen for that particular sample, is going to determine what's actually done here, of course. And you may have more than one sample analysis here that you can actually choose between to see different analyses that are done here. This analysis is pretty much the same. One interesting thing happens if we click here. Now you see there's an error status here. So what this is telling us is that this particular sample has had 3 replicates run for it. One of those replicates is just fine, but 2 of the replicates have unknown analysis. What this means is that at the time that this replicate was done, the correction interval that surrounds it actually had 2 or more analyses turned on. So we don't know which analysis should be used, which replicate analysis should be used in this table in order to do the sample analysis. That's an open question. So you have pull-down menus here that help you decide that, that let you decide that. So you see now we have a choice of 2 different things. We can either do a standard clumped analysis, or we could do an ETH-PBL analysis. So I'm going to choose the ETH-PBL for that one. But for this one, let's choose the clumped one. So why you would choose one over the other really depends on what your lab's doing at that particular time and which one you trust more, things like that. They should give you the same results though. So an ETH-PBL calculates the same things that a clumped analysis does. It just calculates it in a different way, so you'll get slightly different results. Okay, so now we've modified these 2 drop-down boxes, and our status is now empty. And if I go up here and say save, that new information, our selections, have been sent to the database and stored in the database. And now this sample analysis has the information that it needs to do its work. So now we have 2 replicates in our sample that were done with an ETH-PBL analysis, and we have one that was done with an old, with a heated gas style clumped analysis. 2 different analysis tactics, and you can see that the different fields exist in one than the other. So for example, the ETH-PBL generates a PBL version of the carbon values, but the clump doesn't because it's not a PBL analysis, so there's no PBL field here. So these intermittent columns may be different. However, what's going to be the same in all cases is the final values. So if we look at these values, for example, here's our CAP 47 final. Because this has a final word here in the parentheses, it means that all of our replicate analyses must have it in order to do the sample analysis. So you can see it didn't matter which replicate analysis we used, it still had this value The values were then summed up at the sample level, and that was done for a few others as well. And then those values were then used to calculate the various clumped isotope temperatures that this particular analysis supports. So that data that we saved is actually saved in the database, so in the future when we look at this particular sample, it will know to choose these two, that we prefer those two. And this is done on the sample level, so the owner of the sample gets to choose that information. It's not done on a global scale or anything like that. It's done individually. So users, as they're looking at their samples, will have to go through occasionally and set appropriate things as the lab changes, as the lab settings change. The only thing I haven't mentioned here are the steps. The steps in the sample calculations are similar to the steps in a replicate calculation. Basically, you get a big table. The table consists of the replicates and an empty sample, and then these steps go through and modify the table, just like in the replicate analysis. So we can choose any step. We can see the documentation for it, see what its input-output is, and parameters and graphics are not implemented for any of the current steps, but they do exist. If you wanted to see, for example, the temperature documentation, you can see which equations are supported for the temperature calculations and how the scaling factor is applied for the acid fractionation. All that stuff is documented here. And that's a brief overview of how the sample analysis works. You may favor using the export screen over the sample analysis screen, but occasionally you have to come to the sample analysis screen to modify parameters or something like that. So that's why this screen's here.